Okay guys, thank you for joining my premier membership program, and in this video I will discuss about the forces you need to consider whenever you are going to design the foundation or the anchor bolt of any vertical vessel. So in case if you do not know what is vertical vessel, in that case, well, this is a very important equipment related to oil and gas industry. And if you look closely to any vertical vessel foundation, it looks something like this. Here you can see that simply a vessel transported like this, and then it is installed over a foundation which is already built on the side. Now what you need to do, you simply need to fix up the connection between this superstructure and this substructure by using some bolt, and these bolts are known as anchor bolt. Okay, that's it. So now how you need to design this anchor bolt, or what are the forces and why this type of forces comes on to this anchor bolt. Okay, so let's discuss one by one. So this is simply a typical picture of installing a vertical vessel in any process industry. Okay, so here you can see that the load which are coming to any vertical vessel or vertical column, whatever you can call it, these are normally gravity load. Okay, so if you consider the gravity load, there is no problem for this gravity load. Why? Because this gravity load simply transferred to this foundation, and you don't need any type of anchorage to transfer this gravity load, because this gravity load is compressive in nature, and just by the action of gravity is simply transferred from this vertical column to this foundation. You don't need to use any anchorage at all. Okay, so why we need to use the anchorage? Let's say instead of having some gravity load, you also have some lateral load. Okay, why? Because of the wind, or maybe due to the earthquake load, or maybe some piping load, you will also have some lateral load like this. So if you do not fix these two parts in this location, what will happen? Once you apply this lateral load, this vertical column will simply shifted to a new place. Okay, just like this. Your foundation will be here, but you will shift your column to somewhere else. So it is not at all required, or it is not at all our desired. Okay, so what we have to do in that case, you have to simply fix this junction by using some anchor bolt. Okay, so now this sliding of this vertical column due to this lateral load is restricted. Okay, so once you have restricted this sliding, now what will happen? You have some lateral load, and you have fixed this base by using some anchorage. Okay, so once you have fixed this base due to this lateral load, what will happen? There will be some bending moment acting like this due to this lateral load and the fixing of this base. So due to this bending moment, what will happen? There will be some tensile force and there will be some compressive force, and we don't need to bother about this compressive load. We only think about this tensile load. Why? Because this tensile force try to uplift your vertical column in this region. Okay, so it simply try to uplift, or you can say that this bending moment try to tilt this vertical column like this. Okay, so here you have solved the sliding problem by fixing it by using anchorage. But once you have provided the anchorage, now there will be some extra uplifting or tensile force because of the end moment due to this lateral load. So here you can see that we need to bother about two type of force. First one is the tensile force, which is trying to uplift your vessel in one side. Okay, and second one is your shear force, or the forces which is causing the sliding of your vessel. Okay, so to design your anchorage, you need to consider two type of forces. So first consider the shear force. Let's say you have used this anchor bolt. This is your foundation concrete, and this is the anchor bolt, and above this there is the superstructure. Okay, so once you have applied the shear force like this, what will happen? This shear force simply try to fail this anchor bolt by the action of shear. So if this is your bolt, okay, you have applied some shear force here, and if you have less diameter of the anchor bolt, in that case there will be some failure in this plane. Okay, so you need to ensure that this anchor bolt have sufficient shear strength against these forces. Okay, now what will happen if you have sufficient strength? In that case, the bolt will be perfectly okay under the action of shear force. It will not fail here. Then what will happen? This bolt will then apply some thrust on the adjoining concrete. Okay, and due to this adjoining concrete thrust, what will happen? There is a chance that this concrete will fail. Why? Because concrete is very much weak in tension, and you, by applying these forces, you are creating some tensile force in this plane, so your concrete may fail. Okay, so these, all of these are concrete breakout failure. Here you can see these are concrete breakout failure. Not only that, if this frontier is strong enough, in that case it may draw some crack at the behind of this application of shear force. Okay, and that is known as concrete pry out. And in all of those cases, what you have to do, simply you have to put some extra reinforcement so that they do not fail. Okay, so how you can provide the reinforcement? Just let me erase. Okay, so here you can see that the crack is occurring along this plane, so you need to provide the reinforcement like this. Okay, so here this reinforcement will take care about this tension, okay, due to this sliding shear force. Similarly, this shear force reinforcement here you have already provided in this side, so this pry out action also will be resisted. Okay, now come to the tension part. So we have encountered the shear force by increasing the strength and the diameter of the anchor bolt sufficiently, and also we have resisted the concrete breakout and concrete pry out by providing this extra shear reinforcement, okay, in this anchor bolt zone. Now come to the tension. So again, this bolt, if it is subjected to tension, it may fail if it doesn't have sufficient diameter and the strength. So you have to provide, or you have to check that the diameter as well as the strength of the bolt is sufficient to carry the tension. Okay, simply if the diameter is known, then you can find out the area, and if you know the allowable strength, tensile strength, in that case you can find out the tension carrying capacity, and this must have to get then the applied tension. Okay, now what can happen if you have sufficient strength to carry the tensile force? Then it will transfer this tension to the concrete like this, because the bottom has some anchorage by using some washer or bolt. So now this whole concrete zone is trying to go away due to this tensile force. So to resist this crack again, you have to provide some reinforcement like this. Okay, so again this vertical reinforcement, initially due to shear we have provided the horizontal reinforcement. Now due to this tension we are providing the vertical resistance or the vertical reinforcement. Okay, so if you have also resisted the vertical crack, then what can happen? Simply the concrete will remain intact, the bolt will remain intact, but the bolt will simply coming out due to this tensile force, and this is known as pull out. So to resist this pull out, what you have to do? You have to increase the bonding between the bolt and the concrete, because if this is the concrete block and let's say this is the reinforcement and you are trying to pull it out, so what will happen? There will be some frictional resistance, So if you increase this frictional resistance, your pull out will be resisted. So just to resist this pull out, what you have to do? You have to ensure that there is sufficient embedded length of the anchor bolt. Okay. So if the embedded length is very less, in that case, your anchorage may fail under pull out action. But if you have sufficient length as well as end anchorage in terms of some washer or bolt, then this tensile force cannot pull out this anchor. Okay, so that's it.